Okay, for our third learning objective, we might see either a double slit problem or a problem about diffraction grating. This particular example that I'm doing deals with the diffraction grating. So we're told our diffraction grating has 800 lines per centimeter. So 800 lines per centimeter. Now, we don't want to do centimeters. We know there's 100 centimeters in a meter. So we'd have 80,000. Oops, did too many zeros. Lines per meter. The reason that we want to know this is that D is 1 over this. Because this would give us the measurement between adjacent slits. This would be 1.25 times 10 to the minus 5 meters per line. That just tells us what is the separation between two adjacent slits on the diffraction grating, and this is what we use in our expression for where we want to find maximum. We're looking for d sine theta is equal to m lambda. So we're told that the second order maximum, that's m equals 2, is found at an angle of 25 degrees relative to the central maximum. So theta is 25. And we're trying to find the wavelength of light that produces this. So we're going to say lambda is d sine theta over m. We're just rearranging that expression. We have our value of d that we just found. We were told our angle was 25 degrees for a second order, which is m equals 2. And we find our wavelength is 2.64 times 10 to the minus 6 meters. So that is our answer for part A. For part B, we want to know the separation between adjacent maximums if their distance to the screen is 2 meters. So we're saying from here to here is 2 meters. And what we're trying to find is we want to find y2, and then let's also find y1. And we're looking for the difference between them to see how much they're separated by. When we did the double slit experiment, we were able to use the approximation that the sine of theta and the tangent of theta were the same. This doesn't work because these angles are much too big to use that approximation. So we are literally sort of looking at this triangle in order to find y2 and y1. So the tangent of theta 2, that would be the one for the second order, is y2 over the 2 meters. So y2 is 2 meters times the tangent of 25, and that turns out to be 0.93 meters. And then if we want to find y1, that's going to be for the first order, because we want to figure out the distance between the second order and the first order. And I forgot, I have to find theta 1. So I'm going to just kind of go over here, find theta 1. M equals 1. So 1 times my wavelength, 2.64 times 10 to the minus 6 equals d sine theta. Sine theta 1. So since I ran out of room, I'm not going to rearrange this, but I think you can do that. My angle where my first maximum is going to take place, not the central maximum, but the first order one, is 12.2 degrees, and that's the number I want to put in here. I forgot I needed to find that before I did this calculation. And then finally, I want to find the difference between y2 and y1, because that's how far they're separated by. Would be 0.93 minus 0.43, so it's 0.5 meters is the difference between the two. That's it.